AP Statistics with Gracyn
Sarah,
and Aram.
introducing the p-value. What is a p-value?
So a p-value is the probability, likeliness, or unlikeliness of obtaining a test statistic that is at least as extreme as the one that was already observed, assuming that the null hypothesis, HO, is true. So basically, what are p-values used for? And they are...
We use p-values to see how likely or unlikely it is for the null hypothesis to occur, the chance of HO being true. With enough evidence, your p-value being virtually zero, you can reject HO and accept the alternative hypothesis, which is your HA.
So p-values just let you know whether to accept or reject HO and how likely it is for HO to be true. So we will need the mean of the population parameter, which is the symbol in parentheses, and we will need the mean of the sample statistic, which is X bar.
Standard deviation. Using the standard deviation formula, we can then gain all the information and components to discover the p-value of the problem. The standard deviation formula is square root of p times 1 minus p divided by n.
So how can we calculate p-values? Well, when we calculate our z-score using the formula z equals x bar minus mean original divided by standard deviation, which is also divided by the square root of n, we get our z-score. And once you get the z-score, you go into your AP Statistics book and look at your table A, which should be in the front of your book. And when you go there, you use your z-score to find the p-value. So this is your table A. So on your left-hand side, you have your z-score. And as you go across to the right, you will find the p-value that matches up with it. And this is the negative table A.
What do p-values indicate? When your p-value is under 5% or 0.05, you can simply reject your null hypothesis and accept the alternative hypothesis. If they are above 5% or 0.05, we can accept our HO and reject HA.
So we can calculate the p-value by using t-tests or z-tests. We're going to do an example now, so you don't have to write this down, but I would write down the information given. The Survey of Study Habits and Attitudes, SSHA, is a psychological test that measures the attitude towards school and study habits of students. Scores range from 0 to 200. The mean score for U.S. college students is about 115, and the standard deviation is about 30. A teacher suspects that older students have better attitudes towards school. She gives the SSHA to 25 students who are at least 30 years of age. Assume that scores in the population of older students are normally distributed with standard deviation 30. The teacher wants to test the hypothesis. Your HO is mean equals 115, and your HA is mean larger than 115.
We will use the z-test formula. Z equals x bar minus the mean original divided by the standard deviation over the square root of n. So the first thing you're going to do is you're going to take z equals 118.6 minus 115 divided by 30 divided by the square root of 25, and you get 3.6 divided by 6, which is 0.6. And you're going to look and you're going to make a bell-shaped curve, and the book gives you to the left, which is 0.7257, but you want to the right because you want greater than. So you want to take 1 minus 0.7257 because under the bell-shaped curve is equal to 1. And so your answer for your p-value is 0.2743.
Of course, you can always find your p-value on your calculator. So using your graphing calculator, you click Stat, which is shown in the picture circled in red. And then this screen will appear and you will scroll over to Tests and click number 1, which is your z-test. And go ahead and highlight the stats instead of data because you're going to enter all your stats in. And for your original mean, we have 115, which is also your population parameter mean. And then your standard deviation is 30. and your sample statistic mean is 118.6, and your sample number of students is 25. And then for your HA, we are looking for greater than, so we put greater than the mean. So on your calculator, once you click enter, you get this answer. P equals 0.274253. So this is exactly what you got while you did it with hand, except it was just the number given from the table A, so it might differ a little bit.
You can also use a t-test to find the p-value. You use a t-test when you are not given the standard deviation. The formula of a one-sample t-test is t equals x bar minus the mean divided by the sample over the square root of n.
The sample standard deviation.
Yeah, because you're not given the regular standard deviation.
When using a t-test, you have to use your degrees of freedom, and your degrees of freedom is your sample size minus 1.
Example 2, finding the p-value using a one-sample t-statistic.
So this is found in your book. It's example 11.7, and it is the one sample t-statistic for testing. It's on page 627. So your HO is mean equals 0, and your HA is mean greater than 0. So this is from a sample of 15 observations, and the t-value is 1.82. So n equals 15, and because of that, your DF is 14. So that answers number A, which is what are the degrees of freedom.
Using table C, find the DF row on the very left. In this case, it is 14.
Scan to the right until you find the t-value. In this case, closest to 1.82. So here we underline the point in which the t-value lies, which is between 1.761 and 2.145. And then we use the arrow to point up to the coordinating p-value, which is between 0.05 and 0.025. So give the two critical values of t from table C. What are the right tail probabilities p for these two entries? So they give us the t-value, which is 1.82, and the DF is 14. So then we look where the p-value is at 1.761 and 2.145, and those are the right tail probabilities.
And then it says for C, between what two values does the p-value of the test fall? And you go up to your p-values, and it's between 0.05 and 0.025. So for D, is the value t equals 1.82 significant at the 5% level? Yes, it is significant because it is under 5%, because between 0.05 and 0.025 is under 5%.
Is it significant at the 1% level? Is no, because it is not at 1%, but 5% is enough to accept your HO and reject your AHA. Unless it asks for a 99% confidence interval. So the p-value can also be determined on your graphing calculator through a t-test. First, click Stat, seen circled in red in the picture. And then this will appear. So you scroll over to Test and click number 2, which is your t-test. And then you will enter in all of your numbers on your calculator and click enter, and you will get an exact p-value instead of an in-between like we did while we used section C, table C in your book. So that is how you find p-values.
The end.
Thanks from all of us. All right. Oops. Sorry guys, I have to figure out the snag it.